think that. The cynical side of me says it's a false negative, which means I have to test it again next term, and next term, and next term, and next term. But we'll get back to that. So I'm going to come over here. I'm going to crack up the distribution graph we're getting. So this is the graph that you actually, I want to rewrite my program so it shows this graph. That's the curve that you guys are actually testing on. That's the null curve. That's the null curve. The bottom number on this curve is showing you deviations from what Mars said. So if we got exact agreement with Mars, we would have landed right there, 0. What has happened in every single case, and if you go through the letters that are next to my office, we always were landing out here, which means grave deviation from what Mars said was supposed to happen. Where did you guys just land? You landed right here. Right there. So I'm gonna go ahead. Dude, this is freaking ridiculous. There. Your p-value came in around 82%, right? Which essentially means your p-value is here and shaded all the way to the right. That's almost 100% of the curve, which means there's almost no deviation from what Mars said. So in other words, for the first time in the history of me doing this experiment, the letter I'm going to write to Mars is not going to be, what did I used to write when we were over here? What did I used to write to him when we were over here? Hey Mars, guess what? Your percentages are wrong. What does the letter have to read now?
Good job.
Holy crap! Of course, I'm going to caveat that with, I think it's a false negative. We're going to check again next term. Keep that on that. Because I can't look at almost 50 tests that say one thing and then one comes in false negative and be like, oh, problem fixed. Problem might be a burp and it might be a hiccup. But this is freaking ridiculous. This has never happened.
Production dates on the 2 boxes of M&M's.
Oh my god, are they fresh?
I don't know. These are all. No,
I never even thought about that too, because this box, that's a good point, Frankie. This box was from last term, and last term was wrong. Last term, you can actually see it right here, friends. Thank you, Frankie, for pointing that out. Last term was here. This was last term's numbers. Not you guys, last term. This is last term's. Here, I don't have the graph here, I don't think. See how orange and blue and green are off from last term? So that box, who grabbed their bag from this box here? The original box that was open, there's only 3 or 4 bags, I think, right? I never thought about that, I mixed and matched. So the dates.
On the side, this side.
Oh! Best before May 2014, yay. Best before May 2014, and we also have lot numbers. 319 BRC BO2. I must have bought them at the same time.
Same lot.
I bought them at Costco probably, but at the same time. So maybe they're what? Now this is even more ridiculous, because that means that the box that was used last class
It's vastly different.
is vastly different than the box I bought at the same time at Costco. First thing I thought was a false negative. But here's the thing. Imagine you're right. Imagine you're the researchers and you got this result right now. Finish the test. Finish the test. What's the conclusion? It does not appear that Mars is good. Exactly. Now, good. Bailey's going, wait a minute, time out. This is where it's going to sound a little bit weird, and you can say it a couple different ways. One way to say it is, it doesn't appear that the proportions are off in any way. Another way of saying it, maybe if you don't like double negatives, is just say that you don't like, okay, let's say that one. It does not appear the proportions are off. Let's just say that. It seems like you like that one better. Or maybe you hate it less. Let's just start with, let's just say it does not appear the proportions are off in any way. So I know it seems weird to circle it does not appear, but remember, we always circle that when we get a big p-value, because you're checking for a change. It does not appear there's a change, which technically means that Mars's numbers look like they're supportable. I think it's a false negative, though. Especially looking at that. I wouldn't have thought to do that, Frankie. That's very good research on your part. Looking at the dates. It's the same lot, which makes me think we just got some goofy, deviant, false negative data. What's the chance of that false negative? Won't answer that question because you can't. Remember, you have an exam question that helps you answer that question. That helps you determine. You know what the chance of a type 1 is. We could make a type 2, right? Of course, we could make a type 2 error. But I can't ask you right now what's the chance of that type 2, because there are too many variables floating around to measure that. You don't know. Here's the hang on. Here's the null curve. And we know what the chance of a type 1 error is on the null curve, right? We know what the chance of a type one error is on the null curve. It's anything that trips out 5%. So we test at that level. The chance of a type 2, this isn't the curve for a type 2. Type 2 error would be, we say everything's fine when it's not. The fact that it might not be fine means there's some other curve floating around. And without knowing where that curve is, we can't identify the probability of a type 2 error. You'll have an exam question on that, so you'll mess with that later.
So this is a type 1 error?
No, this is a type 2, because it's a big p-value, right? It could be a type 2 error, because it's a big, I just can't ask you what the chance of that is.
Okay.
In other words, I can't ask you, and this is something you'll see in later math classes, maybe the power of the test. The power is the complement of a type 2. Power is like confidence. It's like equivalent to confidence. So I can't ask you what the power of this test is until you know what the type 2 error is. And that's why you have an exam question on it, because it's actually an interesting idea, but it's not worth getting into now. So historical. You researchers, though, you're going to be like, dude, why are you getting so worked up, Rule? Why are you getting so worked up? Look, we got it. Mars is right. But for years, Mars has not been right. That's my point. All this data that I finally started collating says that Mars isn't right. Look. This is from my time at COCC that I've been collecting it, and before that, I wasn't keeping track of it in Excel. Every single one of those years had a teeny tiny p-value. As a matter of fact, I have the Excel spreadsheet set up to expect it to be off, because in the letters I've written in the past, the p-values were so tiny that I actually compared them to doing silly things like flipping a coin 120 times and always getting heads, or dealing cards out to somebody and dealing like 5 consecutive royal flushes, which are very, very unlikely, because that's what the probability was like. And then you guys come along and ruin it. I love it! I'm almost positive it's a false negative.
So in order to really get the facts, you have to almost take every one of the same lot number and add them all up.
Yes, which is cost prohibitive, right? So Frankie, just the only way to remove all suspicion is to count every candy, but then you can't sell anything, which means you can't bring in any money to pay for the candy. You just crash tested all your products, right? You got really good. You got zero margin of error. You also have zero profit margin.
At some point, they have to have done that.
Well,
to come up with it.
I'm not sure how much they care about this, but I'm excited. I have to write a brand new letter for you guys. What I do is every term, I write a letter to Mars, and I have you guys all sign it and mail it off, and then I get a rejection letter. So I'm curious now to write a different letter talking about congratulating them and saying, I'm sure I'm going to check you from now on anyway, because I want to make sure there wasn't false negative, and see if I get the exact same form letter back.
And then but interestingly, the boxes were the same lot number.
Oh, yeah, I'm fully going to mention
Yeah.
that. I'm fully going to mention that, which makes me think about being, oh my God, this is freaking amazing. I'm blown away. You guys don't have to be blown away at all, because you haven't seen it for 15 straight years. You haven't seen the same result come back 15 straight, and then finally see a negative result and go, wow, why? Most likely false negative. The reason I bring this up is, remember the study I mentioned a few weeks back about multivitamin spike cancer? I brought that up in passing. Well, studies for years and years and years and years and years were coming back negative, and then one study came back positive. Well, to me, that screams false positive. I mean, you expect 1 in 20 to be a false positive anyway. This screams false negative for the exact same reason. If I keep getting consistent results, and then one pops up, it could be one of two things. Maybe the proportions have changed. This makes it hard to believe for me because of the same lot number. But maybe they have. In which case it's a legit big p-value, and they actually are now paying attention to the percentages. I can't believe they would actually change anything because of some loud hippie writing up letters for 15
It wouldn't be
years.
the same lot number anyway, though. It would be
That's true. That's why I think it's a false. That's why I think it's a false negative, because it shouldn't be the same. If it's different lot numbers, I'd be like, okay, maybe something. Uh-oh, we got stray data on the ground there. It's all right. He's already been counted. Let's been counted. So let me show you. This is crazy. This is freaking ridiculous. Let me show you what a small p-value in a chi-square looks like. Because I was fully expecting one right now. I'm glad that I went to Ricardo's talk last night, because now I actually have data that shows you. We got big p-values. iPod was a big p-value, meaning the iPod randomizer was behaving. Mars was a big p-value, meaning that Mars's percentages are behaving, at least from our data. So finally, we have nothing to show you for a small p-value.